Welcome to a lesson on angles of convex polygons. The goal of the video is to determine the sum of the interior and exterior angles of a polygon. Every convex polygon has interior and exterior angles. The interior angles are the angles inside the polygon formed by the sides. So for this pentagon there are 5 interior angles. Angle 1, angle 2, angle 3, angle 4, and angle 5. The exterior angles form a linear pair with the interior angles. So if we look at angle 2 for a moment, we can either extend this side here to form the exterior angle, or we can extend this side here to form the exterior angle. It doesn't matter which side we extend to form our linear pair. Let's go ahead and extend this side here. And then I'll go ahead and work my way around the pentagon, extending each side. So I'll extend this side here, this side here, this side here, and this side here. Notice we have a 5-sided polygon, and I extended 5 sides to form the exterior angles. So looking at angle 1, angle 6 forms a linear pair with angle 1, and therefore is an exterior angle. Here we'd have angle 7, angle 8, angle 9, and angle 10. Each of the blue angles form a linear pair with the red interior angles. Now before we talk about the sum of the interior and exterior angles, let's review the sum of the interior angles of a triangle. Remember, the sum of angle 1, angle 2, and angle 3 is always equal to 180 degrees. And just to demonstrate this, let's go ahead and take a look at a Wolfram demo. Here we have a triangle. If we determine the midpoints of side AB and side AC, they would be here. If we connect the mid segment, we would have this, and then we'll construct the perpendiculars from these midpoints to the base. And now we'll make folds across these segments. 1, 2, 3 folds. And now we can see very clearly that angles A, B, and C would form a straight angle, or would have a sum of 180 degrees. So let's use that information to determine the sum of the interior and exterior angles of some convex polygons. So for this first triangle, we know the sum of the interior angles, angle 1, 2, and 3, would be 180 degrees. Now let's go ahead and label the exterior angle. So we'll extend each side starting here. And so the exterior angles would be angle 4, 5, and 6. Well, the sum of the interior and exterior angles would be 180 degrees times 3. Since angles 1 and 4, 3 and 5, and 2 and 6 form linear pairs, we know their sums would be 180 degrees. So this will give us 540 degrees. And if we subtract out the sum of the interior angles, or 180 degrees, we'd have the sum of the exterior angles. That's going to give us 360 degrees. Now for the interior angles of a quadrilateral, we're going to break up the interior into triangles, since we know the sum of the interior angles of a triangle would be 180 degrees. Using that logic, we can see that there would be 2 triangles in the interior of a square, and therefore the sum of the interior angles would be 180 degrees times 2, or 360 degrees. And then when it comes to the exterior angles, we'll go ahead and extend each side. So if we label the interior angles and the exterior angles, the interior and exterior angles make up 4 linear pairs. So the total sum would be 180 degrees times 4. It's going to be 720 degrees. And if we subtract out the sum of the interior angles, which is 360 degrees, we would have 360 degrees as the sum of the exterior angles. So notice how the sum of the interior angles is changing, but the sum of the exterior angles is staying the same. Let's go ahead and try at least one more. For the pentagon, we can divide the interior into 3 triangles. Therefore, the sum of the interior angles would be 180 degrees times 3, or 540 degrees. And if there are 5 interior angles, there would be 5 exterior angles. So we'd have 5 linear pairs. So the sum of the interior and exterior angles would be 180 degrees times 5. It's going to be 900. Subtracting out the sum of the interior angles, again, leaves us with 360 degrees. So once again, notice that the sum of the interior angles is increasing while the sum of the exterior angles stays the same. Let's go back and see if we can notice a pattern. Notice that the polygon has 3 sides. We can think of this as 180 times 1. For 4 sides, we have 180 degrees times 2. And for 5 sides, we have 180 degrees times 3. So you probably can see the pattern, which leads us to the following theorem. The sum of the measures of the interior angles of a convex polygon with n sides is n minus 2 times 180 degrees. So we take the number of sides, subtract 2, multiply by 180 degrees, and it gives us the sum of the interior angles. And the sum of the measures of the exterior angles of a convex polygon is always 360 degrees. Let's take a look at an example using these theorems. Here we want to determine the measure of each interior and exterior angle of this regular polygon. Remember, if it's regular, the lengths of all the sides and the measure of all the interior angles are equal. So let's first count the number of sides we have. 1, 2, 3, 4, 5, 6, 7. So it's a heptagon, and n is equal to 7. So we'll start by finding the sum of the interior angles. Using our formula, we're going to have n minus 2. Well, there are 7 sides here, so we'll have 7 minus 2 times 180 degrees. That's going to give us 5 times 180. That'll be 900 degrees. So the measure of each interior angle would be 900 degrees divided by 7, since we have a regular polygon. Here we'd have to perform long division. It'd be 128 and 4/7 degrees. Let's go ahead and show where this came from. 900 divided by 7, that'd be 1, subtract, that's 2, bring down the 0. How many 7s in 20? That would be 2. Subtract, that's 6. Bring down the last digit. How many 7s in 60? That'd be 8. The remainder of 4, so we put 4 over 7 for 4/7. Now for the sum of the exterior angles, we now know that it will always be 360 degrees. And since we have a regular polygon, the measure of each exterior angle will also be the same. So we'd have 360 degrees divided by 7. That'll be 51 and 3/7 degrees. And again, let's go ahead and show that as well. So we'd have 360 divided by 7. There's 5 7s in 36. And there's 1 7 in 10. So we have 51 and 3/7. Now remember, keep in mind this only works because we know it's a regular polygon. If it's not regular, each interior and exterior angle may not be the same. I hope you found this helpful. Thank you for watching.